Hi, in this video I'll be demonstrating my EECS 3215 project. The original project plan was to create an alarm clock specifically designed for people who have the habit of hitting snooze on their alarm clock, but due to some unfortunate circumstances I had to fall to my backup plan. More details about this can be found in my report. So for my project for embedded systems, I built a stopwatch. Before going into the technical details for my project, I'll first demonstrate how the stopwatch works. In this embedded system, I'm using an LPC 802 board along with a 4-digit 7-segment LED display and a buzzer. The control of the stopwatch is handled through two buttons that can be found on the LPC 802 board. The button on the leftmost is used to start or stop the watch timer. The button on the rightmost is used to reset the timer back to 0. The stopwatch can go up to 99 minutes and 99 seconds. The embedded system is powered by my laptop. A battery isn't being used in this system. The code for my project has already been uploaded to the chip. The stopwatch begins by displaying a time of 0 seconds and waits for the user to provide input. Once the user presses the start-stop button, the watch begins incrementing the timer in seconds and the buzzer goes off to inform the user that their watch has started. To stop the timer, the user can once again press the start-stop button and this will pause the timer. And once again, pressing the same button, the timer will continue where it left off. Lastly, the user can reset the stopwatch using the reset button. This will reset time to 0. Now, let's move to the technical aspects of this system. As mentioned before, the system is made of three main components: the LPC 802 microcontroller, a 4-digit 7-segment display, and a buzzer. The 4-digit 7-segment display consists of 4 common anode pins that are connected to pins 10, 14, 11, and 17 of the LPC 802 board. Each LED anode is connected to the board using 8 330 ohm resistors. The digital pins of the 7-segment display control which digit to display, and the individual LEDs are used to display numbers. So activating digit 4 and turning on LEDs at position B and C will display the digit 1. For the buzzer, the anode wire is connected to ground and the cathode wire is connected to pin 16 of the LPC 802 board. Initially, this pin is inactive and it is only activated when a user presses the start-stop button. We have looked at the configuration, so now let's dive deeper into the code. There are two types of interrupt in the system that are used to drive the stopwatch: user-generated IRQs and timer-generated IRQs. A user IRQ is issued when a user presses the start-stop button or the reset button. When the start-stop button is pressed, an interrupt is issued to keep track of the stopwatch timer and a buzzer sound is heard. When the reset button is pressed, an interrupt is issued to reset the stopwatch to its initial state. There are two timer IRQs used in the system: SysTick and MRT. SysTick issues an IRQ every second, and if the stopwatch state is in the running position, then seconds are incremented and displayed on the 4-digit 7-segment LED display. MRT issues an IRQ every 0.25 millisecond and displays each digit on the 7-segment LED display for a short period of time, turns off the display, then displays the next digit on the next 7-segment LED display. This is done very quickly for all 4 digits on the 4 7-segment displays, and to the human eye, it seems like the 4 digits are being displayed simultaneously. Over the course of this project, there were several changes made to the original project requirements for a stopwatch. Some changes were made to improve the performance of the stopwatch, while other changes were made due to difficult circumstances. A more detailed view of these changes can be found in the project report. Despite not meeting my original goal, I have managed to create a working stopwatch embedded system with a supporting buzzer sound when the user starts or stops the stopwatch timer. My project probably isn't something to brag about, but considering the circumstances that I've worked in, I'm still proud of the outcome. Thanks for taking the time to watch my project video.